Hello students, myself Abhishek, your master physics teacher, and I welcomes you all today in the Tapasya Live digital channel, YouTube channel. And today we are going to discuss a very interesting topic of projectile motion through a very interesting animations that I am going to show you. Now, maybe some students, most of you would have already studied about this topic and most of you are going to study about this topic. Now, this simulation will going to help you both of you. Like those who have already studied, it will give you a very practical approach to approach the questions, and for those who are going to study this topic, it will give you a lot of curiosities about the concepts of projectile motion, and you know that knowledge always comes from curiosity. So let's start this topic. Firstly, I will tell you about the simulations. Let's suppose, what is projectile motion? Firstly, let's understand. The basic definition says that projectile motion is what? When you throw a particle at any angle theta, at any angle from the ground, it should follow a curved path and it should move under the action of gravity. Let's see, is it working also or not? So I have taken a shell here, okay, and I have taken this shell and I will fire a particle from here. Let's suppose I have given a particle. You will notice that when I have thrown a particle, it is moving in what kind of path? Curvical path, and we call this path as parabolic path. We will prove that also in equation of trajectory. We prove that it is a curvical path, but as of now you can see that it is following a curved path, and this motion is called as what? Projectile motion. Okay, now you would be curious about that whether this acceleration is acting in also or not. That I've told you that this complete motion is coming under acceleration due to gravity. So for that, let's check about the component of acceleration that again I am going to project. Okay, let's make it little bit slow and let's change the angle this time and let's project it. See, you can very clearly see that there is a component of acceleration that I have selected, and now it is coming only in the downward direction. All of you know this basic thing, that acceleration due to gravity always comes in the downward direction. So it is also it is confirmed that this complete motion is acted by the acceleration due to gravity. Okay, now we will talk about velocity. If someone has solved this topic, they know that always we do make two components about the velocity vector, one in horizontal direction, one in vertical direction. So let's see how they are getting varied. So let's clear this and have the components of velocity from here. Now let's see what is happening. Now here very beautifully it is represented that you are having two components of velocities. Two components means one is horizontal velocity. Again, if I will do this, one is horizontal velocity and one is vertical velocity. You will notice a very interesting thing, that this vertical velocity is continuously decreasing, and at the maximum height it was 0. That means if I will talk about what kind of motion it have performed, it was two components of motion. One was, this was vertical velocity, this was horizontal velocity, and you have watched that this horizontal velocity through the motion was always constant. That means if I am drawing at this point, if I am drawing at this point, if I am drawing at this point, at every place this horizontal velocity is always constant. Reason for that, it is very simple, because there is no acceleration in horizontal direction. That means there will be always a constant velocity. But in y direction, as we know that there is an acceleration in downward direction, that means this component of velocity that is going in perpendicular vertical direction, it is going to be changing with time. Okay, and what is the relation between that? We say that Vy is equal to Uy minus of G to T. You can see that clearly it is varying with time. Even we are discussing these things a lot in depth. As of now, we are just having the feel of projectile motion. Okay, so let's remove this. Okay, now we'll talk about the some very interesting points about projectile motion. That when projectile motion, I will tell you one more thing. This point from where you are projecting anything is called as point of projection. This path is already, I have told you, this is called as equation of trajectory. This angle, you can make it is, I guess it is able, you are able to see that there is a 50-degree written. This is called as angle of projection. What is angle of projection? It is the angle that is made by the vertical to the particle. Okay, so this is the angle with which you are projecting it, and this height, let's suppose if I will take it, this height that is attained by the particle is called as maximum height, or also written as h max. There are lots of formulas also for these things. Now we are not entering into the formulas, we are just having the feel of this concept. This complete distance from this initial position to final position, the distance that you have covered in horizontal direction, is called as what? Range. Those students who have solved this topic already, they know very better way in about these terms. The time taken from this point for the particle to come at this point is called as time of flight. What I am saying, time of flight, and I represent it by TF. So these are some basic terminology that I expect you have understood about it. And now we are going to see some very interesting things about this projectile. Now maybe you will be curious. So let's suppose, sir, I am changing the let's remove this firstly. Let's change the angle, and I am interested to watch that what will happen. See what will happen. A projectile is going like this, and now the range is changing and the maximum height is also changing. That means it was affected by the angle theta. Okay, now those who have solved this topic, they know at what angle you will throw so that the range that you are getting will be maximum. If any student knows, they can answer in the comment box what is the angle at which range will be maximum. Correct, 45 degree. So let's see, is it getting 45 also or not? Let's have some projectiles. First I am projecting it at 65 degree. Let's see what is the range we are getting. Okay, fine, this is the range. I have removed this. Now let's decrease this also. Let's have tried at 30 degree. Okay, this one, it has having greater range. But what I am saying, it will always have the maximum range. Maximum range means, again I am saying, it is the maximum horizontal distance covered. It will always be coming at what degree? 45 degree. So let's make it 45, and I am assuring you that it will come maximum. Let's see here, this was 15 meter, this was 17 meter, and this is nearly 20 meters. So always remember one thing, that maximum range is attained at what angle? 45 degree. Okay, there is one more very interesting concept of projectile motion, that complementary angles. I guess all of you know, if you want two projectile angles and you want that both of them have the range as same, okay, and that means you are projecting at two angles, theta 1 and theta 2, and you want the range same. So what should be your angles, theta 1 and theta 2, guys? So what you can do, you know about complementary angles, it will be same if theta 1 and theta 2 are equal to 90 degree. That means theta 1 plus theta 2 is equal to 90 degree. So let's check it whether it is coming also or not. So first time, let's suppose I am making this angle to 60 degree, a standard angle, that's why I am taking. Okay, and let's project your particle. Is it working? Okay, so where your particle is landing, let's suppose somewhere around 17.4 meter. Now what I've told you, the range should be same at what angle? Theta 1 plus theta 2 should be 90. If one angle I have taken 60, that means second angle will be how much? 30 degree, for making it complementary. Correct? And now it is very interesting. Let's check whether it is coming same or not. Let's see. You will see exactly same position you are getting the range. So this is the concept. There is complete formulas for it, for time of flight, range, and horizontal maximum, and what is maximum height for everything. Equation of trajectory, why we call this as parabolic path. We also prove that there is a quadratic equation. So students, as of now, I just wanted to give you the feel of this topic. Okay, what we are going to study about velocity components and acceleration components. We are going to analyze this complete 2D motion. It is called as 2D motion. Into 1D motion, basically we break this complete motion in y direction and in x direction, and then we analyze everything and we derive in complete depth. For that, if some students are interested, they can join our batches. The link is in description. Just fill the Google form, and for that moment we will start also next time I will come with some better concepts. For that much time, thank you so much.